Hello friends, today I am going to start a very important subject, that is basically signals and systems. This subject is very important because so many questions you will find from this subject in GATE exam, in IES exam and other competitive examinations. This is a very fundamental subject. You must understand the subject and clear your concept. If you clear the concept on this subject, then definitely you can able to answer almost all the questions, whatever the questions you will ask in the competitive examination. So my friends, take it seriously and try to thorough in this particular subject, signals and systems. This subject is not only essential for electronic students but also very essential for electrical students. So therefore, try to clear your concept on this particular subject, signals and systems. Now let me start. Signals and systems. It is basically a mathematical subject, full of mathematics. But today I will discuss only just the introduction part. That means theoretically I will say some part of introduction of this topic, signals and systems. Now before discussion of this particular subject, signals and systems, let me explain first what is basically a signal. Now let me define what is basically signal. So in layman language, you can say a signal is nothing but anything which contains information. Then what is an information? An information is nothing but anything which contains uncertainty. See, it's very interesting. Anything which contains information, that is known as a signal. Anything which contains uncertainty, that is known as an information. Then what is the meaning of this? Suppose I am doing this. Now you understood what I am saying. I am calling you. So this thing contains the information that I am calling you. Now you understood and definitely you will come to me. So this I can see as a signal. Because this thing contains information. And that information you understood. So therefore I can say this is basically a signal. So anything which contains information, that is known as a signal. And anything which contains uncertainty, that is basically known as an information. Then what is basically uncertainty? Suppose I am saying sun rises in east. No, this will never convey any information to you because that is already known to you. Sun rises in east. But if I will say today there is a heavy earthquake in Delhi, New Delhi. Now so many questions in your brain. I am telling true or false. First question. Then if there is the earthquake in Delhi, then how many persons died? What amount of earthquake is there in Delhi? So many informations, so many questions coming to your brain. So therefore this statement convey information because this thing was not known to you previously. So therefore definitely it contains some amount of information. Hence you can say anything which contains uncertainty, that is basically known as an information. Again I am repeating, what is basically signal? In a layman language, in dictionary language, you can say a signal is nothing but anything which contains uncertainty. And what is anything which contains information. And what is an information? Anything which contains uncertainty. That is basically known as an information. So this is just the layman definition of a signal. But as an engineer, you must know the mathematical definition of a signal. How to define a signal mathematically? What is the mathematical definition of a signal? So in mathematical point of view, you can define the signal in this manner. So what is the definition of a signal mathematically? Any physical quantity which is a function of another physical quantity or quantities. Or you can say any physical quantity which is a function of an independent variable or variables, that is basically known as a signal. Again I am repeating, any physical quantity which is a function of independent variable or variables, that is basically known as a signal. Then what is an independent variable? Independent variable is basically taken as another physical quantity. So how to define a signal? Any physical quantity which is a function of another physical quantity or quantities. It may be plural. That means a physical quantity may depend on one physical quantity, or it may depend on two physical quantity, or it may depend on three physical quantities. That means if a physical quantity depends only on one physical quantity, then the signal is known as a one-dimensional signal. If a physical quantity depends on two another physical quantities, that means you can say that a signal is nothing but known as two-dimensional signal. Similarly, if a physical quantity depends on three another physical quantity or three independent variables, you can say, then the signal is known as three-dimensional signal. In this way, you can have multi-dimensional signals. But here, we will give concentration only towards one-dimensional signal. That means any physical quantity which is a function of only one another physical quantity. That is basically known as a signal. Generally, the independent variable is taken as a time. Actually, you can take any other physical quantity, but in our discussion point of view, we are limiting the independent variable as time. That means any physical quantity which is a function of time, we can say that is basically a signal. Then what is actually physical quantity? Physical quantities are those quantities which are obtained from the physical processes. Then what is a physical process? Physical process is the process, or it is the phenomenon which is occurring surrounding us and are sensed by our sense organs. Simple definition. So what is a physical process? Physical process is a phenomenon which is occurring in our surrounding and are sensed by our sense organs. So now from this physical process, whatever we are getting, that is known as a physical quantity. Suppose this marker is dropped. Now we are observing it. This marker is dropped. And this is sensed by our eye. Now if I will say what is the position of the marker with respect to time, then that position is basically known as a physical quantity. So that means any physical quantity you can get from the physical process. So any physical quantity which is a function of independent variable, that is time, is known as a signal. In a broad sense, you can classify the physical quantity into two categories. One you can say scalar quantity, other you can say vector quantity. Physical quantity, two categories: scalar quantity, vector quantity. What is a scalar quantity? The physical quantity which are expressed only by magnitude, that is basically known as a scalar quantity. For example, suppose it's a length. Length is expressed by meter. You can say 10 meter. 20 meter. So it cannot say 10 meter north. It does not convey any information. You cannot say 10 meter north. You cannot say 10 meter south. You cannot say 100 meter east. You should not attach any direction whenever you are saying 10 meter, 5 meter for length. Suppose 10 kg north, it does not have any meaning. 5 kg east, it does not have any meaning. 2 seconds south, what is the meaning of 2 seconds south? So therefore, whenever you are expressing the quantity only by magnitude, that is known as a scalar quantity. Now, you can see there are so many examples of scalar quantity: length, mass, time, temperature, etc., etc. All are basically the scalar quantities. You cannot say 10 degree north, 10 degrees centigrade north, 20 degrees centigrade south. So therefore, this is basically known as a scalar quantity, the quantity, the physical quantity which you can express only by magnitude, that is known as scalar quantity. Then what is basically vector quantity? The quantity which can be expressed not only by magnitude but also by direction. That means along with magnitude you must attach a direction with it. So quantity which are expressed both by magnitude as well as the direction, that is basically known as a vector quantity. Okay. So anyway, the physical quantity may be scalar or it may be vector. So this physical quantity or this physical quantity, if it depends on another physical quantity, and I have told the another physical quantity means the independent variable we are taking as time. If this physical quantity or this physical quantity depends on time, then you can say that that is basically a signal. So you may consider x is a function of t. So x is any physical quantity. If it depends on another physical quantity t, this thing is basically known as a signal. So x may be force, may be velocity, may be electric field intensity, may be magnetic field intensity. If it is a function of time, then this total is basically known as a signal. This is the notation which is used for signal mathematically. Very simple. So again I am repeating, what is basically a signal? In layman language you can say a signal is nothing but anything which contains information. Then what is an information? Anything which contains uncertainty, that is basically known as an information. Then mathematically how to define a signal? Any physical quantity which is a function of independent variable or variables, that is basically known as a signal. The independent variable is taken as another physical quantity. That means you can say any physical quantity which is a function of another physical quantity or quantities, that is basically known as a signal. If a physical quantity depends on only one physical quantity, then the signal is known as one-dimensional signal. If a physical quantity depends on another two physical quantities, then the signal is known as two-dimensional signal. If a physical quantity depends on three independent variables or three another physical quantities, then you can say that the signal is three-dimensional signal. In this way you can have multi-dimensional signals. But here we are concentrating only towards one-dimensional signal. And in general, the independent variable is taken as time, because whatever our analysis point of view, we are considering the independent variable as time. That means any physical quantity which is a function of time, that is basically known as a signal. This is very simple. The physical quantity may be scalar, may be vector. Scalar quantity you can express only by magnitude, length, mass, time, temperature, potential. Vector quantity you can express not only by magnitude but also with a direction. That means you can say force, electric field intensity, magnetic field intensity, etc. So whatever the physical quantity may be, the quantity may be scalar, may be vector. If it depends on time, then you can say that that is basically a signal. Now a signal is named according to x. X is basically dependent variable, because in every signal t is common, independent variable is common. So if force depends on time, that is force signal. The name of the signal is force signal. If a velocity depends on time, this is velocity signal. If electric field depends on time, this is electric field signal. So in this way you can name the signal. So this is just the introduction, just the idea of a signal. In my next video I will cover classification of signal. That means basically you can say with respect to time, the signal having two classifications, continuous time, discrete time. With respect to x is thought about the amplitude. With respect to amplitude, the signal also having two classification. That means you can say continuous amplitude and discrete amplitude signals. Actually, in this subject, I will solve thousands of questions. So my friends, be patient. So let me explain something theoretically so that you can have interest on this topic. Then I will derive everything. I will solve problems. Each and every problem, whatever the problems are, I have already asked in GATE. That problems also will solve. Along with thousands of problems, I will solve in this topic, in this subject. So therefore, time to time, please kindly see my videos. Thank you very much. In my next discussion, I will make the classification of the signal. That means how to define continuous time signal, continuous amplitude signal, discrete time signal and discrete amplitude signal. So thank you very much.